Welcome to Deep Dive Ortho. Today we're embarking on a truly fascinating deep dive into one of the human body's most extraordinary networks, the immune system.
Mhm.
Now, most of us know it as our defense against illness, but its role is, well, it's far more intricate than just fighting off a cold.
Absolutely.
It's a sophisticated guardian, maintaining balance, keeping us alive. We'll be exploring the remarkable complexity and crucial relevance of this elegant defense, especially for you, our listeners, as medical professionals. Joining me is the eminent Prof. Mo Imam.
It's a genuine privilege to be here. The immune system, I think it's fair to say, is arguably the most profoundly impactful area of medical science unfolding right now.
Really is accelerating, isn't it?
It really is. Our understanding, it's not just evolving, it feels like it's undergoing a revolution. So we'll shed some light on its influence, not just fighting disease, but maintaining physiological balance, helping recovery from injury, even shaping how we interact with the world.
And that touches every specialty, including orthopedics.
Precisely.
Yeah.
In ways we're only just beginning to fully appreciate and, importantly, integrate into clinical practice.
Right, then let's truly unpack this. Many of us in the medical community, we have that foundational understanding from, basic physiology or pathology. But if you were to characterize its fundamental role, beyond just fighting off a common cold, what truly makes it an elegant defense?
Well, at its core, the immune system is our body's essential defense network. It's an unparalleled piece of biological engineering, really, honed over millennia. Think of it as a vigilant, incredibly smart guardian that never rests.
Never rest, that's key.
Exactly. And its elegance lies in its astonishing complexity, its remarkable ability to distinguish with incredible precision between self, what belongs to us, and non-self potential threats.
That's non-self distinction.
It's absolutely paramount because it allows the system to deploy this almost infinite array of strategies against threats, bacteria, viruses, even rogue cancer cells, and all while crucially preserving our own healthy tissues. It's about precision, adaptability, and that constant vigilance.
So it's much more than a passive shield. It sounds like an active, ongoing process surveillance, response, even repair. Could you elaborate on those core functions? What's this internal security force actually doing day in, day out?
Precisely. It's dynamic, it's relentless, its core functions are multifaceted. Firstly, there's constant surveillance. Think of it like a highly sophisticated, decentralized security force patrolling every corner of the body.
Everywhere.
Everywhere. From the moment we're born, it's scanning for anomalies, anything that shouldn't be there. This allows it to rapidly identify and neutralize pathogens, bacteria, viruses, fungi, often before they can cause widespread damage.
Right.
But it goes beyond just fighting external invaders. It's deeply involved in tissue repair and regeneration. Think about any injury, a cut, a fracture, even a surgical incision.
Our bread and butter in orthopedics?
Exactly. Immune cells are the first responders. Neutrophils, macrophages, they rush to the site, initiate inflammation, clear out debris, and crucially send out signals, cytokines, growth factors that recruit other cells to start building new tissue.
That orchestration is vital for healing.
Absolutely critical, especially in orthopedics. Think of a complex fracture, the immune system's precise control of inflammation, new blood vessel formation, bone formation. It's paramount. Too little activity, healing is delayed. Too much, you get scarring or even non-union. It's a delicate dance.
A very delicate dance.
And furthermore, it's constantly clearing cellular debris. It's the body's cleanup crew. Old or damaged cells are removed through apoptosis, programmed cell death, and the immune system ensures their components are safely recycled or disposed of.
So it prevents waste buildup?
Exactly, preventing unnecessary inflammation. All these roles contribute continuously to overall homeostasis, keeping our internal environment stable and functional.
That ability to distinguish self from non-self and adapt. It sounds like something refined over a very long time. Is that the evolutionary perfection you mentioned?
Absolutely. It's a magnificent testament to evolution, honed over millennia. Think back to our ancestors, the infectious agents, environmental challenges, constant risk of injury.
A tough world.
A very tough world. Only those with robust, adaptable, discerning immune systems survived and reproduced. So it speaks to its deep-seated, sophisticated design. It's not static, it's dynamic, learning, self-correcting.
It learns.
It learns. Think how quickly it responds to new threats, new viruses, antibiotic-resistant bacteria. Yet it must maintain the integrity of our own body, avoiding self-attack. That's immensely complex. This constant coevolution with pathogens has given it an amazing capacity for recognition, response, and critically long-term memory.
Like remembering past infections?
Precisely. It remembers past invaders, allowing a faster, stronger response next time. That combination of precision, adaptability, and memory makes it astonishingly effective.
That complexity sounds immense. Can you shed some light on the key players who are the foot soldiers and generals? And crucially, how do they communicate across this vast system?
It's a beautifully orchestrated cellular army, a legion of microscopic cells, each specialized, all linked by this almost instantaneous communications grid.
Instantaneous, wow.
Almost. Let's start with the B cells. They originate and mature in the bone marrow vital tissue for us in orthopedics. Their key function is generating antibodies. That's humoral immunity.
The antibody factory.
Exactly. When a B cell meets a specific antigen, say a protein on a bacterium, it transforms into plasma cells, churning out these Y-shaped antibodies. They target and neutralize pathogens, either directly or by tagging them for destruction by other cells.
Opsonization, right?
Opsonization, yes. It's highly specific and memory-driven. Once a B cell responds, future encounters trigger a faster, stronger antibody response. That's the basis of vaccination, of course.
And relevant for things like prosthetic joint infections.
Very relevant. Targeted antibodies might aid diagnosis or even treatment down the line. Then we have the T cells, the generals, and elite soldiers. They also start in bone marrow but mature in the thymus gland.
The thymic education.
A critical process. They learn rigorously to distinguish self from non-self. It involves positive and negative selection, vital for preventing autoimmunity. T cells have dual roles. Some are direct fighters, cytotoxic T cells, CD8 plus ARID. They're assassins, destroying infected or cancerous cells by inducing apoptosis.
Ordering them to self-destruct.
Precisely. Vital for controlling viruses and tumor surveillance, including musculoskeletal tumors we see. The others, helper T cells, CD4 plus ARID, are the directors. They don't kill directly, but orchestrate the whole response.
The conductors of the orchestra.
A perfect analogy. They release chemical messengers, signaling to B cells, cytotoxic T cells, macrophages, coordinating the defense. Their proper function is essential for a balanced response.
And there are others too, NK cells.
Yes. Can't forget the natural killer, or NK cells. Another type of foot soldier, but part of the innate immune system. They provide a rapid, non-specific response. No prior exposure needed.
Innate, so faster.
Faster? Yes. Particularly good at eliminating virally infected cells and tumor cells. They recognize cells that have lost their normal MHC markers, a common sign of infection or cancer. Unlike T cells, they don't need specific antigen presentation. They're the rapid response unit, containing threats before the adaptive response fully kicks in.
So these cells work together seamlessly, but how do they achieve that real-time coordination across the whole body?
That's where the communications grid is vital. Molecules like cytokines and chemokines are absolutely key. They're the chemical messengers, small proteins allowing diverse immune cells to communicate rapidly and effectively.
Like sending signals.
Exactly. Cytokines mediate and regulate immunity, inflammation, even blood cell formation. Some are pro-inflammatory, like IL-1, IL-6, TNF-alpha signaling danger, activating cells. Others are anti-inflammatory, like IL-10, TGF-beta, dampening the response, preventing damage, promoting healing.
A complex messaging system.
Very. And chemokines are a specific type, directing cell migration. They act as molecular homing beacons, creating gradients that guide immune cells, a neutrophil to bacteria, a macrophage to tissue damage precisely where needed.
So they guide the troops.
Precisely. This intricate chemical signaling ensures a coordinated, swift response, wherever the threat arises. Without it, the system would be chaos. In orthopedics, understanding cytokine profiles is becoming important, say, in diagnosing PJI or predicting bone healing.
So these specialized units communicating via sophisticated signals, putting out fires everywhere. Given all this, what's one of the most critical overarching objectives of this entire system?
You've hit on a crucial point. A major fundamental role, overarching everything, is to keep infection out of our circulatory system. The bloodstream is the body's superhighway.
A route to every organ.
Exactly. An uncontrolled infection there can be catastrophic sepsis, multi-organ failure, death. Think in our orthopedic context. A localized infection, maybe around an X-fix pin or early osteomyelitis.
A nightmare scenario.
If unchecked, it can spread rapidly via the blood to other joints, bones, even heart valves or kidneys. The immune system has evolved robust mechanisms to contain and eliminate threats before they gain systemic access.
That's why even local infections cause systemic symptoms. Fever, raised markers.
Precisely. The body isn't overreacting, it's working intensely, pulling out all stops to prevent that local breach from compromising the blood. It's a continuous high-stakes battle. That's why we monitor our ortho patients so closely for any sign of infection.
Right, here's where it gets really fascinating. For all its complexity and power, the immune system isn't invincible. It seems almost paradoxically fragile, susceptible to Modi Mwesh. What are some key factors weakening this fragile wonder weapon?
It is a critical paradox, isn't it?
Yeah.
Despite its robustness, it's surprisingly susceptible to contemporary stressors, many pervasive in modern society, impacting us healthcare professionals too. Well, firstly, lifestyle factors. Chronic fatigue isn't just feeling tired, it significantly impairs immune function. Adequate sleep isn't just for cognition, it's vital for immune reorganization, cytokine production, cell trafficking.
And things like shift work disrupt that.
Absolutely. Data shows circadian rhythm disruption common for night shift doctors. Many patients directly impacts immune cell trafficking and cytokine production. Even subtle clock shifts can disarm defenses. Chronic stress, too common for us in our patients facing surgery or chronic illness, releases cortisol.
Which suppresses immunity long term.
Exactly. Chronically, it can suppress some immune functions, push towards inflammation, impair wound healing, and poor nutrition lacking micronutrients like vitamins D, C, zinc, or high in processed foods deprives immune cells of building blocks and energy,
All things that impact patient recovery.
directly and profoundly, affecting post-op recovery, infection susceptibility, rehabilitation success. A fatigued, stressed, poorly nourished patient is less resilient to surgical trauma.
What about environmental factors?
Yes, environmental toxins. Chronic, low-level exposure air pollutants, industrial chemicals, microplastics. Some household products can compromise immune health. They overwhelm detoxification, cause oxidative stress, damage immune cells, leading to chronic low-grade inflammation or misdirected responses.
And age. We see that impact clinically.
Undeniably. Advanced age leads to immunosenescence. Immune function naturally declines. Fewer diverse T cells, reduced antibody responses. The thymus shrinks after puberty, impacting T cell output.
Leading to increased infection risk and reduced vaccine effectiveness.
Correct. A major concern for our elderly patients facing surgery. Slower healing, higher complication rates.
And paradoxically being too clean.
Somewhat, yes. The excessive hygiene aspect captured by the hygiene hypothesis or old friends hypothesis, reduced exposure to diverse microbes, especially early in life, might hinder proper immune system development and training.
So it doesn't learn to distinguish harmless from harmful properly.
Potentially, leading to hyperreactivity allergies or breakdown of self-tolerance, contributing to autoimmune conditions. It's nuanced, not advocating poor hygiene, but highlighting the need for balanced microbial exposure for immune programming.
And what happens when that fragile wonder weapon turns on itself? You mentioned epidemic levels of autoimmune disorders. What's going on there? Can you give us a concrete example?
This is where elegance tragically becomes pathology. Autoimmune disorders occur when the system mistakenly identifies parts of our own body as foreign threats and attacks healthy tissues.
A failure of that self-tolerance mechanism.
Exactly. Normally, sophisticated mechanisms prevent self-reaction. But in autoimmunity, this fails complex reasons, often genetic predisposition plus environmental triggers. T and B cells attack self-antigens. This causes chronic inflammation, progressive damage. Symptoms vary hugely depending on the target.
Like rheumatoid arthritis attacking joints.
Precisely. Or lupus attacking multiple organs. Often chronic, debilitating, requiring lifelong management, frequently impacting musculoskeletal health.
And a really impactful example.
Let's consider type 1 diabetes. Not metabolic lifestyle diabetes, but classic autoimmune disease. The immune system attacks the pancreas, specifically the insulin-producing beta cells in the islets of Langerhans.
The cells that regulate blood sugar.
Absolutely crucial. The immune system misidentifies them as invaders, systematically destroying them. This leads to profound, absolute insulin deficiency. The patient needs external insulin to survive.
Devastating.
It truly is. It perfectly illustrates how a misdirected immune response, failed self-tolerance, has systemic, life-threatening consequences.
Yeah.
It underscores the delicate balance and catastrophic outcomes when it's lost. We see the musculoskeletal complications of poorly controlled diabetes all the time.
To really appreciate where immunology is now, understanding its journey is helpful. What are some key historical milestones that laid the groundwork?
Our current knowledge builds on centuries of discovery, often driven by devastating epidemics, forcing us to find answers. Early hints came from the Black Death in the 14th century.
Really? That early?
Rudimentary observations, yes. People noted survivors seemed immune to later infections. It hinted at acquired resistance long before microbiology.
Fascinating.
The real scientific detective tale accelerated in the 18th, 20th centuries. Vaccination is perhaps the most famous milestone. Jenner's work with cowpox and smallpox in the late 18th century,
An empirical leap.
an astounding one. Later, Pasteur advanced the science with attenuated vaccines. Vaccination showed the immune system learns and remembers, giving us the first tool to manipulate it for protection. Then, Fleming's discovery of antibiotics in 1928, developed by Florey and Chain in the 40s.
Penicillin.
Exactly, the first chemical weapons against bacteria. These twin innovations, vaccines boosting host defense, antibiotics killing invaders, reshaped medicine. For orthopedics, the impact was profound. Open fractures were often death sentences pre-antibiotics.
They transformed surgical possibility.
Completely, reducing risks of osteomyelitis, sepsis. These historical leaps paved the way for deeper investigation into the immune system itself.
And that historical perspective leads us where today? Where are the cutting-edge labs revolutionizing immunology? And what are the most exciting revelations changing lives?
We are truly living through an extraordinary period, with immunology at the forefront. Modern labs globally are making revelations transforming care across specialties, including oncology and orthopedics.
Like cancer immunotherapy.
One of the most profound breakthroughs. For decades, it was surgery, chemo, radiation. Now, understanding immune-cancer interaction leads to therapies harnessing the body's own defenses,
How does that work?
often by releasing the brakes or re-engineering immune cells. Think checkpoint inhibitors drugs, blocking proteins cancer cells use to hide from T cells. Blocking these unleashes the T cells to attack.
So the body fights back.
Precisely. Then there's CRT cell therapy, truly revolutionary. A patient's T cells are engineered in the lab with a receptor targeting cancer antigens, multiplied, then infused back as potent cancer killers.
Incredible outcomes sometimes.
Previously unthinkable outcomes for terminal cancers, advanced melanoma, lung cancer, leukemias, durable remissions, massive implications for orthopedic oncology, sarcomas, bone mets where immunotherapy is increasingly vital.
What else is exciting?
The microbiome. Understanding the trillions of microbes living with us, especially in the gut, and their huge influence on immune development and function.
They train the immune system.
Actively train and modulate it from birth. This symbiotic relationship impacts allergies, asthma, autoimmune diseases, even response to cancer therapies. It's leading to new interventions, fecal transplants for C. diff, targeted preprobiotics.
And relevance for orthopedics.
Fascinating implications, preventing post-surgical infections, influencing bone healing, maybe even implant integration. Systemic inflammation is often linked to gut health.
And better autoimmune treatments.
Yes, deeper understanding leads to more targeted autoimmune treatments. Historically, broad immunosuppression had risks. Now, knowing specific cytokines or cells involved allows highly specific biologics.
Like TNF inhibitors for RA.
Exactly, or IL-6 inhibitors, B-cell depleters for lupus. Modulating only the aberrant response, reducing damage, improving quality of life. A shift from blunt instrument to refined, tailored approach. Directly impacts us, as many joint conditions are autoimmune. Better joint preservation, better surgical outcomes.
It's truly incredible, but how do these powerful therapies in our daily lives interact with the immune system? You mentioned a razor's edge.
Absolutely. That analogy is spot on. The immune system is dynamic, constantly responding. These therapies aren't standalone. They operate within this complex ecosystem. Our behaviors, our environment. It's a continuous, complex dance. It can be for good, but it's always on that razor's edge of function versus dysregulation.
Like inflammation needed for healing, but too much is harmful.
Precisely. Think chronic tendinopathy or non-union fractures where persistent inflammation hinders bone formation. Our daily choices, diet, sleep, stress, powerfully influence this balance. A pro-inflammatory diet can chronically activate pathways. Sleep deprivation impairs cytokine production, lymphocyte function. Chronic stress alters immune cell activity via cortisol. These behaviors either support optimal function or push towards dysregulation.
Which directly impacts our orthopedic patients' healing.
Directly. Optimizing these isn't just general advice. It impacts surgical healing, infection risk, pain management.
So it's not a generic response. It's profoundly tailored to the individual.
Exactly. A critical nuance.
Yeah.
An individual's elegant defense doesn't care about an infection in isolation. It cares how that infection attacks its own unique personal habitat.
Personal habitat. I like that.
It underscores the personalized nature of every response. Genetics, epigenetics, lifelong exposures, microbiome, current physiological state all contribute to this distinct habitat.
So everyone responds differently.
Significantly differently to infections, surgery, even drugs. This influences disease progression, complications, treatment response. It reminds us we treat patients, not diseases in a vacuum. Each is a unique biological context.
Driving personalized medicine.
Absolutely. Recognizing the battle is fought within a unique landscape every time. And it reiterates, again, the paramount importance of keeping infection out of the circulatory system. A continuous, dynamic, personalized battle. Compromise leads to systemic issues.
That's fascinating. And there are even more surprising ways immunity influences us. Something about scent and mate choice.
Indeed. It highlights the pervasive, often subconscious influence. Research shows the major histocompatibility complex, or MHC gene, critical for immune recognition, gives off a unique scent.
A body odor fingerprint.
Essentially, yes. And this MHC-linked scent is a factor, albeit subconscious, in mate choice.
Why would that be?
Powerful evolutionary theory, promoting genetic diversity, enhancing offspring immune resilience. The sweaty t-shirt study famously showed this. If MHC profiles and scents are too similar, it can act as a repellent.
Less attractive.
Yes. Conversely, a sufficiently different MHC scent tends to act as a magnet, increasing attraction. It promotes outbreeding, maximizing genetic variation. Diverse MHC genes mean offspring have broader immune responses, better equipped against pathogens.
Remarkable. Biology interwoven with behavior.
Deeply interwoven, driven by survival and adaptation, showing the immune system's silent, profound influence on our very lineage.
It's so clear that understanding this isn't just academic. It has a profound human dimension. The stories are deeply moving.
Precisely. Advancements aren't abstract. They're illuminated by individual patient stories. People defying HIV, living long lives thanks to therapies supporting the immune battle.
Or cancer patients achieving remission with immunotherapy.
Exactly. Stories of defying terminal diagnoses rising from the grave, as it's been put. Profound hope. And individuals with autoimmunity lives transformed by targeted treatments, regaining function, quality of life.
These stories humanize the science.
They do. They show the tangible impact, the suffering from dysregulation, but also the incredible hope science brings. They provide deep emotional context and highlight the diverse ways dysregulation manifests, sometimes in bewildering ways.
Bringing it all together then, what does this complexity and continuous discovery mean for us as medical professionals considering our patients' overall health?
It means we must cultivate a deeper appreciation for the immune system's central, unifying role in all health and disease, recognizing its delicate balance. As specialists, we focus musculoskeletal for us. But the immune system is the unifying thread, influencing every other system.
It's incredibly complex.
As complex, perhaps more so, than the brain. Countless moving parts working magically together. This intricacy necessitates a truly holistic understanding. We can't view disease or injury in isolation from the body's defense mechanisms.
Which brings us back to holistic care.
Directly. Foundational lifestyle factors, diet, sleep, stress management, physical activity, aren't peripheral. They play a fundamental role in keeping the immune system balanced. Optimizing these significantly supports immune function, improves outcomes.
Better healing, lower infection risk post-op.
Demonstrably so. A well-nourished, rested, less stressed patient heals better, fights infection better, has a better modulated inflammatory response. We have a responsibility to counsel patients on these foundations.
And the risks of tinkering, with immunotherapy, for instance.
A crucial point. While revolutionary, we must acknowledge inherent risks in tinkering with such a complex system. These are powerful interventions. We're only beginning to understand long-term implications, the tightrope walk of modulating immunity without unforeseen side effects like autoimmune reactions or systemic inflammation.
So caution and ongoing research are needed.
Careful patient selection, meticulous monitoring, rigorous research are vital. We need to be aware of these systemic modulations, especially as treatments become common and patients present with musculoskeletal manifestations.
What a truly illuminating and comprehensive deep dive into the extraordinary science of the immune system. We've covered its fundamental role, its complexity and fragility, lifestyle influences, and the incredible breakthroughs in modern immunology. It truly is an elegant defense.
Indeed. Understanding this intricate network helps us appreciate holistic care and the profound impact immunity has on all of medicine. It's a field revealing new layers, challenging us to consider the body's innate wisdom and resilience in every clinical scenario.
We truly hope this discussion has provided valuable insights for your practice and beyond. If you found this deep dive beneficial, please do take a moment to rate and share our show.
And as you reflect on this, perhaps consider this. An individual's elegant defense isn't just fighting an infection, it's intricately woven into their personal biological habitat. How might a deeper, more personalized appreciation of this unique internal habitat truly reshape our approach to patient care in the future, looking beyond pathology to the whole complex individual?